Verify Greens theorem in the plane for integral over c x square minus y square into dx plus 2xy into dy, where c is the closed curve of the region bounded by y equal to x square and y square equal to x. So we have to verify the Greens theorem for this integral where c is closed curve bounded by the two parabolas, y is equal to x square and y square equal to x. These two are parabolas. Okay, so now first the given integral is integral over c x square minus y square into dx plus 2xy into dy. Okay, now the Greens theorem. Greens theorem is integral over c u dx plus v dy is equal to double integral over r dou v by dou x minus dou v by dou u by dou y. Dou v by dou x minus dou u by dou y into dx dy. So this is the formula for Greens theorem. Okay, so I want to verify Greens theorem. Okay, now by comparing these two integral in the left hand side, the u value, coefficient of dx is u, here the coefficient of dx is x square minus y square. So u value is x square minus y square and v value is dy coefficient, so v is equal to 2xy. From this I want dou v by dou x, dou u by dou y. So from this I want dou u by dou y. It is minus 2y. From v I want dou v by dou x. So dou v by dou x is equal to 2y. So from this, for RHS we want dou v by dou x minus dou u by dou y. Dou v by dou x minus dou u by dou y. So which is 2y minus, this is minus 2y, minus of minus plus 2y, which is equal to 4y. So we can use later on for the RHS. Okay, now to verify Greens theorem, I want to find out LHS and RHS. So first I am going to find LHS. Okay, so LHS of the Greens theorem is integral over c u dx plus v dy. So I want to find out this. But you see, integral over c is the line integral. So we want diagram first. But in the problem they are given y is equal to x square and x is equal to y square. Okay, so both are parabola. So I am going to draw the diagram. Y axis, x axis. Here y is equal to x square is the parabola upward direction like this. This is y equal to x square and x is equal to y square. It is right hand side. Okay, so this is x is equal to y square. This is y is equal to x square. Now these two are point of intersection. Okay, so this is x-axis, this is y-axis. So this is our closed region. This is the closed region. Okay, so now I am going to put a name. This is origin, you take it as 0, 0. This is point of intersection of these two parabola. When you solve these two equations, for example, to solve this x value is y square, for example, y value is x square, substituting here. X is equal to y value is x square, so x square of square. So x is equal to x power 4. From these two, x is equal to 0 and x equal to 1. Put x equal to 0 here, y also 0. Put x equal to 1, y also 1. So that the point of intersections are 0, 0, 1, 1. So this is 0, 0. This is, you take it as a 1, 1. Okay. So now I am going to find out LHS of the Greens theorem. So integral over C u dx plus v dy is equal to, it is a line integral. This line is along OA, this direction, plus another line integral along AO. Okay, so integral over C is integral over OA plus u dx plus v dy plus integral along AO u dx plus v dy. Okay, so to find LHS of the Greens theorem, I want to find out along OA u dx plus v dy plus along AO u dx plus v dy. Okay, so now first I am going to find out first line integral along OA. O is the point 0, 0, A is the point 1, 1. Okay, and now equation of OA. What is the equation of OA? You see, this is OA. Equation of OA is y equal to x square. Y is equal to x square, which implies that dy equal to 2x dx. Okay, so now integral over C u dx plus v dy, which is given in not integral over C, integral over OA. Integral over OA u dx plus v dy is equal to integral u dx plus v dy is the given integral x square minus y square into dx plus 2xy into dy. This is along OA. You see, this is single integral, so that I want to convert into single variable either in terms of x or in terms of y by using this. Okay, from this you can put y is equal to x square, then automatically the integral will convert it into in terms of x, or otherwise you can put x is equal to root y, then automatically the equation integral becomes converted into in terms of y. But here easiest one is putting y is equal to x square. Okay, so by using this I am going to convert this integral in terms of single variable, then I can easily integrate. Okay, so now integral for y I am going to put x square. So x square minus y square. What is y square? X power 4 into dx plus 2x into y. What is y? X square into dy. What is dy? 2x dx. So now everything is converted into in terms of x. So I need a limit for x. What is the limit for x here? Limit for x is 0 to 1. Okay, so now integral 0 to 1 x square minus x power 4. I am going to take dx outside commonly, plus 2 2's are 4 x power 4 into dx. Okay, further I am going to simplify. Okay, further I am going to simplify. This is integral over 0 to 1 x square plus 3x power 4 into dx. Now I am going to integrate x cube by 3 plus 3x power 5 by 5, limit 0 to 1. Substituting the limit, upper limit 1 by 3 plus 3 by 5, lower limit 0, so you can leave it. So 5 plus 9, 5 plus 3 3's are 9 by 15, so that it is 14 by 15. So this is integral over OA u dx plus v dy. So next I am going to find out integral over AO, second part. Okay, so here along AO, you see what is along AO? So this is along AO, this part. Okay, so along AO, A is 1, 1, O is 0, 0. Okay, now equation of AO. Okay, you see what from the diagram, what is equation of AO? Equation of AO. This equation is x is equal to y square. X is equal to y square. From this, dx is equal to 2y dy. Okay, now I am going to find out integral over AO u dx plus v dy is equal to integral over, this is given, x square minus y square into dx plus 2xy into dy. Okay, now this is also AO. Again, I want to convert into in terms of single variable, either in terms of x or in terms of y, by using this. For x, I am going to put y square. Okay, so integral for x, y square means x square is y power 4 minus y square. For dy is 2y dy plus 2x, x is y square into y cube into dy. And now it is converted into in terms of single variable y. What the limit for y here? Y limit is 1 to 0. Don't write 0 to 1. It is along AO, from A to O. Therefore, the limit for y is 1 to 0. 1 to 0. So now, integral 1 to 0, take dy term outside. So multiply 2y inside. So 2y power 5 minus 2y cube plus 2y cube into dy. So this and this cancelled. So integration of y power 5 to y power 6 by 6, limit 1 to 0. Substituting the upper limit 0 minus substituting the lower limit 2 by 6. So it is minus 1 by 3. So this is along AO. But I want integral over C u dx plus v dy. U dx plus v dy is equal to integral over OA plus integral over AO. Along OA already we found 14 by 15. So this is minus 1 by 3. So take LCM 15. So this is 14 minus 5. Okay, 14 minus 5 is 9. So 9 by 15 is the LHS of the Greens theorem. So when you cancel this, 3 by 5. So LHS of the Greens theorem is 3 by 5. Now RHS of the Greens theorem, RHS, double integral over R, dou v by dou x minus dou u by dou y into dx dy. Okay, now this is double integral over dou v by dou x minus dou u by dou y. Already we found this. What is that? You see, the value of dou v by dou x minus dou u by dou y is 4y. So that I am going to substitute here 4y into dx dy. But I want to find out the limit for the double integral. Okay, from the region I want to find out this. So what is the diagram? You see, this is the diagram. From this diagram I am going to find out the limit for x and y. But in the multiple integral in the first semester, you have to find out the limit. One limit is variable, another one limit is constant. You can put either horizontal strip or vertical strip. So in this problem I am going to put vertical strip. Okay, so if I am choosing a vertical strip, y limit must be variable, x limit is constant. Okay, so here x limit is constant, so that it is 0 to 1, 0 to 1, and y limit is variable. Y limit variable means it is start from this parabola. You see, this strip is start from this parabola, end with this parabola. Okay, so from this parabola, what is y? Y value is x square. So x square to this strip end with this parabola. From this parabola, what is y? Y value is root x. Okay, so this is the limit for x and y. Suppose you can choose horizontal strip also. If you choose horizontal strip, x limit is variable, y limit constant. That is also you can choose. For example, if you choose horizontal strip, for example, if you choose horizontal strip, then x limit variable, y limit constant. Constant means it is 0 to 1, y limit. Okay, x limit is this strip start from this parabola. From this parabola, what is x? Y square. 2. This strip end with this parabola. From this parabola, what is x? Root y. This is also you can use. You can use any limit, then you will be getting same answer. But here I am going to use only vertical strip, so that I am going to use this limit. X limit 0 to 1, y limit x square to root x. Variable limit is the first integral. So you have to integrate first with respect to y, then with respect to x. Okay. So now I am going to use this integral limit. So x limit is 0 to 1 and y limit is x square. Y limit is x square to root x. Okay, so now first I am going to integrate with respect to y. So take 4 outside, 0 to 1, integrating with respect to y. So y square by 2, the limit for y is x square to root x and remaining integral with respect to x. So cancel this 2. So 2 into 0 to 1, substituting the upper limit, take y for root x. So root x square is x, minus substituting the lower limit x power 4 into dx. Okay, now next I am going to integrate with respect to x. So x square by 2 minus x power 5 by 5. The limit for x is 0 to 1. So 2 into substituting the upper limit 1 by 2 minus 1 by 5. Lower limit 0, we can leave it. So 2 into 5 minus 2, 5 minus 2 by 10. 5 minus 2, 3. So to cancel this, so 3 by 5. So this is the RHS of the Greens theorem. LHS and RHS both are same. Therefore, Greens theorem verified.